Well, give me a little bit of background about what you've been talking about in physics, about sound generation.
Great. Physics class, what are some of the different parts of a wave?
Crest, trough.
Crest, trough, what else? Period.
Amplitude. Sure. Notes. And yeah, absolutely.
Tell them what you know about resonance so far. That's new.
It does indeed. In fact, look around and what we're trying to do, or what the architects are trying to do, is control resonance, so that it doesn't just become a big box and kind of an echo chamber.
We've learned, we haven't learned about timbre or tuning or beats yet, so that would be nice to demonstrate too.
Okay.
We learned that all sound is generated by vibrations,
Right.
but that's about it.
Okay. Probably the easiest instrument to sort of use as a demonstration of a sound generator, and let's face it, that's really all that instruments are sound generators, okay, is a string instrument, because you can actually see it. But since you are playing the largest string instrument in the world, would you please take your bow out. Some of you are going to be able to see this, and some of you aren't. And I might have him kind of turn around. He's going to play one of his open strings, which means he's not going to use a finger.
Excuse me.
And
Behind you.
play as loud as you can. What I want you to see, even from across the room, I think you can watch this. You can actually see the string vibrate. Okay?
Which one?
Play your G string loudly.
Okay.
He said G string.
And you,
I didn't tune, so.
And really what it's doing is it's being held at the top, it's being held at the bottom, and it's vibrating. And the vibrating strings vibrates the air, that's what you're hearing. And then of course, when it comes to changing the pitch, which folks is what we're all about, music doesn't mean much if you can't change the pitch, because a song with one note doesn't really sound that exciting for very long. So changing the pitch on a string instrument is simply a matter of holding the string down so that now the part that's vibrating is shorter. Okay? So just play any note.
Oops.
Okay? And so what you've got is just a little bit shorter length of string vibrating higher pitch. Make sense?
Mm-hmm.
Okay? So that's good. Now, in terms of, who was it that mentioned amplitude? Because we kind of do a lot with amplitude as well. A song that's always the same loudness also doesn't get, that sort of gets kind of boring after a while. So, let me have all of these sound generators play, and let me have them play the first few measures of the piece that they played last night.
Riding the rail.
Oh, riding rail. Okay. Not start with Brooklyn. We'll come back. This is the beginning of the piece. And ladies and
Oh, I'm really excited about this.
3 or 4 minutes. Right? Ready and. Now, before we go very long, I should say that really with string instruments, there's 2 ways to make that string vibrate. And the first way is you take a stick. It's a stick? Oh, really? It is? Okay.
Expensive stick.
It's a kind of an expensive stick, and it has this little crook at this end, and it has this little thing down here at this end. And what that is meant for is to hold this stuff, which most people who don't know any better think, oh, it looks kind of like a big, wide rubber band. but a rubber band really wouldn't work. It's horsehair, and real fast, if I were to draw horsehair under a microscope,
Ooh, microscope.
it looks like this. The cells, as they string along, have these sharp little bumps on them, and that helps, as you drag it across the string, that helps make the string vibrate. And then you've probably watched string players rub some stuff on their bow, rosin. And all rosin does, rosin is actually tree rosin. It's refined and so forth. But like tree rosin, it's sticky. And so what happens when you rub the rosin on the bow is that the rosin sort of collects on all of these little high places on each cell. And so it makes it pull the string even more. All right. So we use the bow, to make the sound. And the nice thing about the bow is that it keeps the vibration going nice and evenly. And then, of course, the other way of producing a sound on the string instrument is just simply take that string and pluck it. So what happened? That's at the end of the first movement?
Yeah.
All right, here you go. Last two measures at the end of the first movement. All right. 3 and 4. And. Okay, so plucking the string just works that way. All right. There is something else that's going on in terms of string instruments that's kind of interesting and kind of fun. I hope that you realize that they're hollow because they're creating their own resonant chamber. And in fact, you would think I was sort of ready.
Yeah, I would actually. Get it? Would.
Don't ask why we cut the bottom of this violin off.
Why'd you cut the bottom of the book?
No, don't ask why we said not to ask.
Sorry.
But it really is.
Ooh.
It really is hollow. It's a box. And the funny thing is, about 350 years ago, literally, they discovered that if they took a piece of wood and they carved it so that the top was curved up and that the bottom was curved up so that it had kind of this kind of thick part here, and they also were thicker around the edge and thinner in the middle, that the top would vibrate like this, and then there's a post that connects the vibrations to the bottom so that the two vibrate together. And they discovered that with this shaped hole and this shaped box and all that kind of stuff, it made it as loud as possible. And ladies and gents, nobody has perfected it or made it any better in the 350 years since then. So really, what you're doing is you're standing around looking at 350-year-old technology.
What's it called when two waves positively add to each other?
It's called what?
Superposition? Constructive interference?
No.
Oh, okay.
No, it's called sympathetic vibration.
Oh, there you go.
I think we're talking about the same thing.
Okay.
And it's a little bit hard to demonstrate that with, I tell you what, you'd almost have to have a violin in your hand to feel it. But if all the cellos were to play an open G string kind of loudly, all the violin players, if their Gs are perfectly in tune with their Gs, their instruments will vibrate. They'll be able to feel it. It's not real strong, but it's.
We did that with tuning forks.
You do it with tuning forks, right? Okay. And so, and it makes sense. You're making vibrations by moving the string. Well, vibrations can also move the string. It can go backwards. Not nearly as loudly, of course, but it does work that way. Yes?
Wolves?
Bows?
Wolves. What are wolves?
Oh, wolf tones. Wolf
I've
tones.
never heard of wolf
The
tones.
design isn't absolutely perfect for every single note that we play. And every once in a while, this shape, well, in almost every instrument, there's a note, maybe a couple of notes that just don't sound, they don't ring, they don't resonate, they don't come out like all the rest of the notes. It's called a wolf tone. And there's not too much you can do about it, except what the maker will try to do is he'll try to tune the top and the bottom so that the wolf tone comes right in between notes that we use. So that it's not like an F natural that we would need, or an F sharp, it's in between. So the only time it would really bother you is if you're playing an F out of tune, and then you get what you deserve. Anything else about sort of what makes it work? We spend our whole lives, you know, trying to kind of make the vibrations do what we want to do so that we control amplitude or volume, we control pitch, or let me put it this way, we try to control as best we can. That's the biggest challenge with an instrument like this, is that obviously pitch is determined by where you put your finger. And you could be off by just the tiniest fraction of a millimeter and it makes a difference. The tiniest fraction of a millimeter.
Ooh.
If I move my finger, you can't see me move my finger that distance from back there, but you can hear the difference in the pitch. It's not big, but it's there. And then, of course, the other thing that we sort of discovered also about 300 years ago was that it's pleasing to sort of imitate the human voice. When you have singers, we like the sound of vibrato. We like the sound of that pitch changing. And so we do the same thing when we play the string instruments by simply kind of like to have that kind of and that sort of back and forth. And all I'm doing is just changing the tuning slightly. Like I say, sort of to imitate the sound of the human voice. Your favorite singers, I would imagine, you hear that vibrato. You like that quality. If your favorite singers were just to sing absolutely, you know, straight pitch, no oscillation at all, I think you'd find that a little bit boring, or you'd find it a little bit cold sounding. You like the warmth of the vibrato. And so we've gotten used to that. And of course, you can think of sort of the extremes of that. Think of opera singers. And you think of they use a big wide vibrato. Why? Because it carries to huge halls a lot better. What else about sound? Oh yeah, so we spend our whole lives here in this room talking about working with and practicing, mostly practicing, putting our fingers in the exact right spot so that we're playing in tune, controlling the bow so that we can go from super soft to super loud. Different kind of tricks, if you want to call them. All different ways of plucking the string. There are a couple of other ways of making sound on string instruments, and we don't like it too much. Sometimes composers like to think that they're being all real, cutting edge, newbie, exciting kind of, and they have you doing things like playing behind the bridge. We don't like that too much. You know, it's not too good. And another thing that they do, they have them hit the string with the stick of the bow, and we don't like that too much because it kind of chips the varnish on the bow, makes your bow ugly. So we don't like that very much. We sort of like just the old ways. There's plenty to do to keep us occupied. Just trying to play in tune. With what we have. So it's kind of okay. Any questions, Ariel?
Harmonics?
Oh, harmonics. Oh, excellent.
We're doing a lab on harmonics right now.
Okay, so for us, what a harmonic means is if you take, that's my D string. If I take my D string and basically cut it in half by just lightly putting my finger on it, What it causes the string to do is, as you know, to now vibrate in 2 equal sections. But it's an octave higher in pitch. And I can cut it again in fourths. And you can keep going, but like most things, it gets sort of impractical after a while. There's other harmonics. In fact, you can do this and hear all the harmonics kind of as it changes. Again, some composers think that's really cool. And they write pieces like that, and we play them for a little while, and then we get annoyed with them about after 10 minutes. Okay? Yeah, harmonics, that's good. Oh, there's been a lot of composers. A lot of composers feel like they have to do something different in order to stand out. So they have people doing, crazy sort of tapping things. But again, we generally don't like it too much because it doesn't really sound that good. We feel like we're sort of harming our instruments by doing that. So. Have you thought about how the sound is produced on, for instance, a brass instrument? Anybody know? Pardon? How fast you? Well, it's not just blowing. In a all right, folks. In a brass instrument, you have to buzz your lips, which is basically like going into the mouthpiece, okay? But because you're doing it in that restricted area and making the buzz, that's what generates the vibration of the air column, okay? And then, of course, to change pitch, then it's a matter of plumbing. Okay? And so you have these valves that say, okay, go this way, and this way is a little shorter than this way, so it makes it a higher pitch.
What about tonguing, like double tonguing?
Double tonguing is when you're playing a lot of fast notes on a brass instrument. Okay? Woodwinds, if you're talking about a flute, you're talking about splitting the airstream as it goes over the whole, like blowing across the top of a bottle. Okay, that's the same principle as a flute. And of course, drums, hit one. Drums are the most basic. Drums are the most. Go ahead, Henry, just hit one. Boom, right there. There you go.
Yay! Woo!
Okay. Yeah, with a drum, that's really the most basic. It's simply an animal skin, and we still do use animal skins, but at any rate, stretched over a resonator, and you hit the animal skin, and the resonator makes it sound louder. About it. Okay? Yeah.
So doesn't the shape of their embouchure also influence?
Oh yeah, all kinds of things that you do with your mouth, whether you're a brass player, flute player, or whatever. And then the reeds, which is basically like taking a piece of paper and a comb, or like taking a piece of grass. Those are all sound generators, and then the whole rest of the instrument is just to make it louder and to change the pitch. Okay? But strings, of course, are our specialty.
They're the most sophisticated.
Well, yes, in some ways. And strings do have a certain advantage. We may not be the loudest instrument ever invented, but we can certainly play softer than any other instrument. You get down right to where it just goes to nothing. Brass instruments, it just stops working if you try to get too soft. It doesn't work that way. And other instruments, the same thing. Just the sound simply stops. It doesn't work. Okay?
Thank you.
Does that sort of cover it?
That does. Thank you.
Excellent. Well, stop by anytime.